Hi, and welcome to an introduction to Galaxias, an R and Python package to convert, standardize, and bundle data into a Darwin Core archive for sharing data with GBIF and other living atlases. My name is Dax, and I'm one of the authors of Galaxias. I'm going to walk you through how Galaxias works in R. I've opened a session in R Studio and started a new R project. I've installed Galaxias and loaded it into R. Here we have a small example dataset containing several observations of birds, specifically a few cockatoo species. And this dataset contains information about what species were observed, the day and time they were observed, and the location of each observation, along with a few other types of info. We now want to share these data with GBIF, so we'll need to create a Darwin Core archive. This will require us to standardize our data into one or more CSV files, provide metadata as an eml.xml file, and provide the structure of our data, a schema, as a meta.xml file. First, let's work on our data. To help us figure out how to get started, we can run suggest workflow. The output tells us a few helpful things like how many columns already match valid Darwin Core terms, whether we have the minimum required information in our data frame to build an archive, and a suggested workflow for how to meet these minimum requirements. Let's try using this workflow to edit our data frame. Here's a workflow I prepared earlier. Using set functions, we've specified which terms match existing columns, added new columns, and edited existing columns. Let's save the output to a new object and run our workflow. Set functions not only update the columns in our data frame, but also run basic checks to make sure the data in each column contains valid values. It looks like our data conforms better with Darwin Core Standard. We can check our progress by rerunning suggest workflow, which will update and suggest anything that still needs to be done. We've made a few more changes, and now we're happy with our data. To use it in our archive, we can run usethis. This function detects whether our data is in an occurrence or event-based dataset, then saves the data as a CSV file in the data publish folder in our local directory, a default folder to store files for our archive. Next, let's start our metadata by running usMetadata template. This creates a markdown template in our directory. The template contains a basic structure and details about the type of information that should be added under each header. Once we're happy with our metadata, we can run usMetadata and specify the metadata file we wish to use in our archive. This will convert our markdown file to ecological metadata language and save this in the data publish folder as an eml.xml file. Now that we have our data and metadata, we are ready to build our archive, which we can do using build archive. Build archive detects whether there's at least one data file and a metadata file in the data publish folder, and builds the schema file automatically if it's not there already. And now we have our data, metadata, and schema files, so build archive can then proceed to package and zip our files into a Darwin Core archive, which we can find in our parent directory. We managed to construct a valid Darwin Core archive using just a few steps. If we want, we can use a few other functions in Galaxias to make sure that our archive is valid, and then we're ready to share our data with GBIF. Thanks for watching.